Hello! In this video, I'm going to show you the basics of using post-processing software, which is an additional software from SM Instruments to process recorded data for CSV series sound camera. After you download and install the post-processing software, open the program. By default, you will see a picture of sound camera in the display section. Post-processing software is used to work with previously recorded data. As a result, sound camera does not need to be connected. The buttons on top of the screen are for functions such as load, play, stop, loop, user position, BMP save, report, help, time, play speed, and bookmark. Using the load button, we can open the file we have previously recorded using the real-time software. The user position or magnifying glass button activates the position level cursor, which can be dragged and dropped at any location in the display with mouse cursor and shows the beam power value at that specific position as a text in the screen. The BMP Save button saves a screenshot of the screen in the BMP format. Report button saves the selected duration of the video in either WAV, AVI, or TDMS formats. Clicking on Help button opens a folder containing post-processing user guide. You can also save a selected duration and frequency band as bookmark. The screen in the middle of the software shows the previously recorded video with beamforming map and text of the related parameters and their values. It also shows the power spectrum graph similar to the one in real-time software. The right side panel consists of functions that control and modify the beamforming map, and it has 3 tabs. The graph in the bottom shows the time signal graph and its controllers. The left side panel is called a Spectrogram, with legends related to Bandpass and FFT filters. The first tab in the right side panel consists of functions such as threshold, image range, and image average. These functions work similar to the real-time software. There is a color bar in the right side of the screen which gives a better perception about image range. For example, if you choose image range of 4 dB, based on the maximum beam power value, minimum beam power value is calculated as maximum deducted by 4 dB. In image average section, reverberate averaging has been added to the existing averaging options available in real-time software. Now your options for averaging based on the environment are no averaging, linear averaging, exponential averaging, and reverberate averaging. For example, the current video have been recorded in anechoic chamber, so reverberate averaging is not considered an appropriate choice. In the bottom of the page, you can modify the bandpass filter, which I will explain more about it in the spectrogram section. Moving to the second page, you can see the distance function, which adjusts the distance between noise source and sound camera. The default value is 1 meter. You can change it based on your knowledge on the distance or using an estimated value. FFT level sets bandpass filter of FFT from a saved data, and it will be explained more in the spectrogram section. Cursor position shows the location of the cursor in the display section, and as mentioned earlier, the magnifying glass turns it on or off. Similar to the real-time software, display configuration section can be set based on the specific requirements for beam power map, transparency, and text color. You can also change the graph shown in the bottom of the display section to time signal or turn it off. In the third page, info window displays the specification of the PC that software is installed on. It also displays the number of frames and size of the loaded file. Image calibration part only shows the calibrated value from real time, and it cannot be modified. The graph shown in the bottom of the software is time signal graph. 2 blue lines at the left and right side of the graph show the starting and ending times, while the red cursor indicates the elapsed time when the data is being played. In Tool option, as you can see, Wave Select mode decides how to handle mouse buttons when adjusting the starting and ending time of the time signal graph. When left button is selected, you can change the start and end time by dragging the blue lines with your mouse left button. With left plus right button, you can change the start line with left click and end line with right click. The left side of the graph shows the playback range controls. Use these buttons to expand or contract the amplitude of the displayed signal vertically. If you have selected a new range between blue lines by clicking on Select button, you can zoom on that range, while clicking on the All button, which selects the whole duration for playback. These two buttons are used to contract or expand the selected playback time signal horizontally, as you can see in this video. Spectrogram is located on the left side of the software and it indicates the frequency range, beam power level, and playback time of the signal. The orange line in the left side displays and controls the bandpass filter in the spectrogram. By clicking on the legend, you can adjust the range and move it up and down. At the same time, you can change the bandpass values numerically in the bandpass filter section in page 1 of the settings. The right side of the spectrogram shows the beam power level. This legend indicates and controls beam power intensity in the spectrogram. It can be adjusted without affecting beamforming in the main display. The value can be changed by dragging the bar on the spectrogram or numerically through FFT level section in page 2 of the settings. The highlighted part is to show the selected playback time and bandpass filter. When the video is being played, the yellow line with the indicator on top and bottom shows the lapse time. For example, the file opened in this tutorial consists of two sources. The left source is white noise and the right one is 2 kHz sharp tone. As you can see, in a wide frequency band, the beam power map only shows the left source because white noise consists of all frequencies and its beam power is dominant. But if you change the bandpass filter to focus on 2 kHz bands like 1900 Hz to 2100 Hz, you can see the beam power value on the right source becomes more dominant. As a result, in case of multiple sources, it is important to set the settings on the appropriate value in order to locate and recognize the noise source. In general, this software is used to process a previously recorded data under different conditions from recording conditions and provides more options to view and analyze the recorded data. Thanks for watching this tutorial and have a nice day.